From blockout to cinematic detail in just a few clicks using XPlacer's powerful placement and optimization tools. Let's go check it out. XPlacer is part of the same environment tool family as XDecal Painter. So if you've used XDP before, some parts of the interface and tools will look familiar. So I will try and focus this video on the differences, and if you want to get more detailed explanation on some of the tools, you can watch the XDP overview video, which I will leave a link in the description, and you can also find it here. So XPlacer does what XDP does for decals, but it does it for meshes and blueprint actors. So instead of placing decals, you can use meshes and blueprints to place them and scatter them in your environments. So the first thing that we'll see is that here on top we have the reset, reload, save, and clear buttons that allow you to do basically the same as in XDP. Basically save the settings here and reload them or reset them. You also have this XP actors and level, which is a counter showing you how many actors are currently in the level. So the first thing, or the first sort of sections, are the sections that allow you to place your actors, and we have brush, spray, path layout, region fill, and sampler. So again, I won't be going into details on all these parameters. It's going to take too long, and you can watch the XDP video. I'm going to show you the differences. First of all, I want to show you that by using the shortcuts Control 1, Control 2, Control 3, etc., you can shift to each of these sections. So Control 1 through 5 takes you to the placement tool sets. The other thing here in the brush that I want to take note of is the stat mode. So we have a stat mode. So when I click on that, you can see that I get this placeholder of the mesh before I actually get it to be stamped in the level. So I just click and you can see that I can get it placed in the level. Now, the nice thing is that you can actually have on top, you'll see that we have this HUD, which in yellow shows you once you've clicked on this stat mode, you have the axis rotation, and you can actually change the rotation on the fly. So basically by hitting Alt X, we can change the axis, and then Control Alt and the mouse wheel allows us to rotate the this placeholder mesh, and once we're happy with it, we just click on it and it just gets placed. And Control Alt R resets everything back to default. So that's what this yellow part of the HUD is, and when I turn off the stat mode, it goes away. You also have this allow painting on XPlacer output. So basically by default, when you paint, the paintbrush avoids to stamp or to paint over existing XPlacer placed meshes, but once you turn that on and I can just click on it, you'll see that I get this sort of I can add meshes to the already placed XPlaced meshes. Below that, you got the radius, spacing, and all these features that, as I said, are in part of XDP. So I'm just going to move along. Here we have the spray. Spray again works similar way. You just click and you get a random selection or a random placement of meshes, depending on which meshes or how many you have in the actor placement slots. The difference between XDP and XPlacer is that we have a dedicated spray radius and spray spacing, and you have the paint radius and paint spacing, which are both independent of each other. So once you change one, doesn't necessarily mean you change the other, and vice versa, so that you are independent, working independently. So below that, you have the path layout. Now, path layout is, again, let's just crank that up a little, and then if I just click, you'll see that I get these meshes painted along the path. You can have multiple paths. You can have chain segments. These are all exactly as in XDP. So again, won't be going through that. Region fill. Region fill, I want to show you region fill. Again, with region fill, there are some shortcuts with how you turn on some of these buttons here. So for example here, if you click on the equal button, you get the plus, and this allows us to create a region. And with the C button, it closes that region, and we get a scattering of these meshes in that region. We can change the clustering, we can change the density if we wanted to, we could change lots of things. I wanted to show you that you could just simply click and drag on these points to change the region. You can click holding the Alt key and clicking on the line allows you to add points as well, so you can refine your region even after you've placed it down. Now, what I wanted to show you about the region fill is this commit impact. Now, because we're working in real time, these are placeholders, and in order for them to become real actors, you would have to click the commit button here. And what this commit impact does, it just tells you how many actors, once clicked, will be added to the counter here on top. So there's 45, and if I click commit, you'll see that that number went to 125, and we can delete the region, and here is the scattered assets. So that's what this commit is. Again, all these so far and all these parameters are more or less similar to what are available in XDP. Now, the next section is only part of XPlacer, and that's the sampler. Now, the sampler is a really cool tool that I really love to use, and basically what the sampler does, so again, Control 5 to get to the shortcut here to get to the sampler. What the sampler does is basically it sample points to any mesh that you click on. So for example here, just clicking on it gives me this these points here, and I get this randomization or scattering of the meshes. Now, there's a lot of options here, and I want to go through quite a few. So first things first, again, we have the same sort of idea, this commit button here. So commit on impact, that will add 1,683 meshes to the total XPlace meshes. And by default, it's set to auto sampling. Now, sometimes you don't want to be continually sampling, especially if you're moving things around. So what you could do is you can turn auto sampling off, in which case you would need to hit Control and left click button to actually get a sample. And if you move the mesh again, it removes the sampling, and again you would have to click the Control left mouse button to get the samples on that mesh. So it's a nice way to work if you don't want to have this continuous sampling, which now, as you can see in auto sampling, when it's on, you can see that it's continuously being sampled. You could also have this preview as points, so if you just want to see the points, maybe it will suit you better depending on what you're working on, how you're working. So that's what this preview as points is. So below that you have the max sample points. It's set to 5,000. If you set this to 0, there's an unlimited amount of meshes that you can sample, but I would advise to always have a number here, whether it's 5,000 or 10,000 or whatever number, so that you're always in control of your scene. So below that we have the actions here, the lock from selection, and I'm going to show you that in a second. But before that, I just want to go through the sampling parameters here. You got the modes per area, density, which is controlled through this density per square meter, so you can increase that or decrease it. You have the fixed count, so this controls exactly how many sample points would be sampled on a given mesh. You have the modulation, which is a noise parameter here, the clustering, which clusters the samples into clumps. You have the noise seed, so you can change that to get a different sample. You have the keep ratio, so from 0 to 1, it starts to randomly remove some of these sample points. So again, another way to vary your distribution. Now below that you have the sampling space. So basically, let's just get some of those more of those samples here. So below that you have the sampling space. So as I said, you have the surface and offset. So if I use the surface and offset, you can see that using the offset here parameter, I can push them either below or away from the normal. You also have the jitter, which is similar, but it's gives a sort of a random value to each sample point. So you have a random distribution along that normal. Below that, you have the point validity, and you have this intersection ray method. So it's by default to off. If I turn it on, and let's get some more, let's turn this off. Let's get some more. Okay, that's good enough. Something like that. So what happens is that you'll see that, so again, you'll see why we need this lock from selection in a while. But what happens is, I'm going to turn this guy on. So what this intersection ray method does, it basically controls or samples only areas of a mesh that are not intersecting or have not been intersected by other meshes. So in this case, I've just added this cube, and I can just I can remove it actually, just so we can see what happens, and then I'm just going to turn it off. And here, and you can see we have samples all around this cube. But once I turn it on and turn on the here the intersection method, and then we just turn it off. Oops, again, I did the same mistake, but let's turn it off. You can see that I can quickly eliminate this part of the sampled mesh. So it's a great way to control which direction or which areas you don't want to have sampled. You have this kill overlapping. So if you have overlapping samples, you can increase this number, and it will try to kill anything that is overlapping. Below that, you got your filtering. So here, these are the normal filtering. So quickly here, for example, in the Z, if I come here, you'll see that just by doing that, I've constrained the sampling just on the positive Z. And then below that, you got the respect filters, which basically, once you click on it, then the filters here, the height, slope, and edge, would automatically take effect on the sampling points here. Now, I said I'm going to show you how this lock from selection works. So let's remove this guy here. So what this does is basically, once you've sort of sampled a mesh and you click on the lock from selection, what happens is that no matter what I do now, that sample remains on the mesh. Now you can change the parameters here and do all the things that you would do normally, but it's a nice way to retain the sample and where you can actually continue working before you commit. Now it's also a necessary tool if you're going to use the object filtering, and this section here is the object filtering. And just to show you how this works, I'm just going to come to here and just turn it on. We're going to open the actors here and just select this guy here. And what you will see now is that we get this filtered object that is sort of removing the sample points from wherever it is. You can, of course, control the fall off radius and the scale to your liking. But anyway, the nice thing about this is that you can have this in real time, and it's possible because we lock the selection of the samples on the host mesh. So that's why this is so useful. And if I clear it, you'll see that I can't do it, because once I click on it, I'm not able to retain the sample so that this filtered mesh can go through it. So that's why it's there. So let me just square this out. So you can see now, we have these samples here or here. This little cap here, I think it's because we have this guy here. So you can see this, how this filtering works. So anyway, that's sample. I think it's one of the nicest tools in the plugin. It's extremely useful, extremely handy to lay out things fast. You can lay different types of meshes and assets on top of each other, and you have a lot of parameters to play with and a lot of things that you can adjust. So these are the basic placement and scattering tools in XPlacer. Below that, we move into the other parts of the plugin. The first one here is the user interface, which again is quite similar to XDP. There is a shortcut here, Control F, and what it does, it simplifies the UI and sort of focuses everything on simply the tool you're working on, the tags, and the active placement. And again, Control F takes you back, and it's a great way to remain focused and work in a more sort of focused way. You have your filters here that I went through. You've got the height, slope, and edge. And again, these are very similar to the ones that we have in XDP. You have the eraser. Eraser affects all. So if I click on this, then you can erase meshes that have not just been placed by XPlacer, but also manually or in any other way. So that's what this is for. Again, same as XDP. Object filtering, I just showed you. It's a great way to sort of add whatever it is that you're scattering, and then just add the filtered objects that you want to be avoided, and that's what that is used for. You have the placement. So placement basically is a way to, number one, you have this overlap padding and overlap padding scale to control the overlapping of assets in case you don't want to have them overlapping. You also have the max outputs and max outputs per commit. Again, another great way to control your assets and how you place them. You do not want to be like without any controls, so these are what these are for, to keep you in check. Below that you have your grouping, so you can name everything again by groups, and then everything is labeled correctly, or by tags depending on what which method you prefer. You have the active tag filters here, which just to show you quickly, you can add your tags in the placement slots, again like XDP. So if I come here, you can just add any tag you want. So, you know, Rux2, very creative. So that's what that is for. And then you can come up here to the tags, and then you can decide which tag you want to be using. So that's what that is for. So let's move on to optimization. Optimization is one of the reasons why XPlacer is such a powerful plugin, in the sense that not only can you place and scatter your assets, but you can also optimize them right here in the plugin. So first thing is that we see is that you have this group filter, which allows you to optimize all the assets placed, or you could actually do it by grouping if you've used the grouping here by labels. You also have this apply mode, which allows you to optimize in place or duplicate and optimize it in case you wanted to retain the initial placement of your assets. And here in this section here, you get a glimpse of what is happening. Now, in order to optimize, of course, you have to click the apply button, but here you have the number of optimized assets. Right now it's 0. You have the committed actors in the level, which is 125, which match the actors up here. Now here you have the draw calls now in the level, which equals 125 draw calls. Now if I come here to the actual asset himself and double click, you'll see that we have one material slot here. This draw calls is specifically to show you how many material draw calls would be or are being used to render these assets. Now, if I just click on the material slot here to increase it, you'll see that now we have 250 draw calls, and if I just continue adding, you'll see that we're just continually adding to those draw calls. So that's what this is measuring. And if I just close this, here you will see that once we do decide on the method, you will see how these values change. Now there's two ways to optimize. You can instance your X-placed assets, or you can merge them. Now you can, once on the instancing side of things, you can have a the instance static meshes or the hierarchical instance static meshes. Now, if you're using Nanite, I would suggest you stick with the instance static meshes, because by default, Nanite does use its own culling, so there's no need to use the HISM. But if you're not using Nanite, then you can switch to HISM. You also have this threshold, which dictates exactly when you can use hierarchical versus instance static meshes. The instance scope, this is global or per slot. Now, if you use per slot, you can control in this little allow instancing toggle which assets you want to be instancing. By default, it's on for any placement slot, but you can turn it off. So, you also have the instant pivot point, so you can change that to center, bottom, top, world origin, or first actor. So that's what the instancing does. It's basically a way to have these assets share the same material and collision properties. So HISMs are ideal for rendering repeated meshes efficiently, especially when individual LOD management is not required, and as I said, like nanite. So below that, you'll see we also have this merge way of dealing with optimization. And what this does, it allows you to bake everything into a single mesh. And here again, you can turn it off or on, and you have the collapse pivot point. The collapse target means that anything within the entire level can be baked. The selected actors, or only what is part of the world partition. And again, the collapse pivot point is the same as the instant meshes. So basically, when you're collapsing your meshes, it's primarily an organization cleanup with some performance benefit, but it is mainly a bake locking step once you're done with all your tweaking. So just also for you to see, we have this visualize toggle here. So once you turn that on, you'll see that basically we can see what's happening. So there is a shortcut for that, Control 0. And when you do that, you'll see that we get these red actors here because none of this has been optimized. And let's just use the auto here, and let's just apply. And you can see now we have this huge optimized box here. And oops, I'm adding actors. Let me just delete that guy. And then let's come here and let's select them. So now all these are one optimized instant static mesh. So it's that easy to optimize your assets. And again, you can see from here, we are now having one optimized asset, and we have just one draw call, one material draw call on these, on all of these placed meshes. So that's the optimization. Below that, we have the placement slots, and I just wanted to quickly show you, we covered the instancing. Oh, here we can add a blueprint here if you want, and what that will do is if you wanted to use a blueprint instead of a mesh, you could use that here. And if there two slots are being allocated, then the blueprint takes over. So if I come here, you'll see that we get the cone instead of the rock being placed. So that's just wanted to mention that. You have the weight, you have the sink. So basically you can increase the sink of maybe it's too high, of the placed asset, and you also have the sink noise. So each time you place an asset, it varies the sink rate based off this noise. Below that, you have your tags, which I showed you. Again, more details on the video in XDP. You have the min-max rotations here and the scale. So here is where you would randomize each of your placement actors. So that's XPlacer. It's a different way of thinking about placement in Unreal. It's built for environment artists and studios that want faster workflows and more control as project scale. If you're coming from XDP, the mindset should feel familiar. Hopefully you can see how using both speeds up things and gives you more room to explore creatively with so many placement options in one tool. And that's it. Thanks for watching, and I'll see you in the next one. Bye.